Today. Excited to spend some time really digging into using Open Policy Agent for infrastructure as code security, specifically today with Terraform for AWS deployments. But if you're using Terraform for Microsoft Azure or Google Cloud, this should apply to you as well. A lot of the same concepts. We're really going to just be looking at how Open Policy Agent can work for infrastructure as code security. AWS Cloudformation as well. So why don't we jump over to the agenda today? And so we'll get into some introductions. On this masterclass, we have my colleagues, Josh Stella, my co-founder, CEO and CTO at Fugue, and Jasper Jeugt, principal engineer and the engineer here at Fugue has really led the charge on implementing Open Policy Agent behind the scenes with the Fugue Cloud Security SaaS product, as well as our Regula policy engine that leverages OPA for infrastructure as code security. We'll take an overview over kind of the cloud software development lifecycle, IAC security, and then we'll really dig into to OPA, how it works and how to put it to work for Terraform security. And at the end, we'll get to Q&A, but want to make sure everybody knows, at any time during this session, if you have any questions about what you're seeing or about how to apply it to your specific use case, feel free at any time to pop those questions into chat or any comments that you might have. We want to make this as interactive as we possibly can and have a little fun as we go. So first, before we jump in, I want to make sure everybody is aware about a new resource that we've made available at Fugue. A couple months ago, we partnered with our friends over at Sonatype to survey 300 cloud security professionals. These are DevOps engineers, security engineers, architects, etc., to get some better insights into the cloud security and compliance issues they're experiencing, the challenges they have, and the level of effort that they're having to kind of put into the problem. It's rich with information and insights. You can get that at fugue.co/report. And my colleague Sivia will post a link in chat to download your copy of the State of Cloud Security 2021. So let's get to a little bit about why we're here. And a lot of this comes from our survey report. We're focused on security, but in a sense, it's about more than just security. It's about moving faster, with just any kind of security concerns in IT, and specifically cloud infrastructure as code, approvals, audits, remediations. These all take time, and that's time we otherwise might be spending building value for our customers and our clients. And we could be focused on creating more value if we didn't have to spend all this time. What we found is half of engineering teams are devoting 50 or more hours a week to IAC security, and another 50 hours of engineering time to making sure that the runtime is secure. And that's a lot. So we want to use policy-based automation to see if we can start knocking those numbers down and being able to invest more in avoiding, breaking security policies. No individual human can keep track of everything that we need to be aware of to operate securely in the cloud. That's where policy-based automation based on Open Policy Agent can really come in handy. So we want to kind of break through this notion that security is the rate limiting factor for how teams can go, because we all know we could be going a lot faster if we were able to automate a lot of this stuff. So before we jump in, let's kind of take just a quick look at the kinds of misconfiguration events we're talking to. This is just a small subset, but these are some of the top ones cited by the professionals we surveyed. And most of these, not necessarily all of them, but most of these incidents that happen in the runtime can be caught pre-deployment, in development, in CI/CD with the right kind of infrastructure as code checks. And that's really what we're here to learn about. All of these things are dangerous in their own ways. Hackers exploit these kinds of misconfigurations to gain access to our environments, discover resources, move laterally, and ultimately extract data, often without detection. So it can get pretty scary if we're making a lot of mistakes, because there's bad guys out there using automation themselves to find these mistakes and exploit them before we can, really move, identify them, and remediate them. So best to catch them early in the process. And what's the scale of the problem? Next slide, please. These are not kind of incidents that happen every once in a while. Half of the teams we surveyed are experiencing 50 or more misconfigurations per day. And a lot of these teams are operating at scale in the cloud and have regulatory requirements and additional internal security requirements to maintain. But this is a high volume problem, as well as a high risk associated with a lot of these misconfigurations. So again, when you look at these numbers, a significant amount of these misconfigurations can be prevented in the first place with the right kinds of infrastructure as code security tools. So why don't I, now that I've pitched this, the problem space in the security report, which I encourage everybody to download, turn it over to my colleague, Josh Stella, who's going to kind of, again, as you can see here, talk about the software development lifecycle for cloud infrastructure and introduce the concept of security at every stage.
Drew, thank you. Are you hearing me loud and clear?
Yep.
Great.
Yep.
Hi, everyone. It's great to be back doing a masterclass, and this one I'm really excited about because Jasper is just a remarkable engineer, and he's done some really, really cool stuff that we're going to get to drill into. But before I really dive in, one thing we try to do with these master classes is keep things a little bit, fun. And also, it looks like we've got another year without a lot of in-person events to get swag. So what we're going to do a few times through this hour, and I'm going to do it in just a minute, is I'll put up a background in Zoom behind me. And that background will be something from computer history or video games or science fiction, anime. And the first person to name what the background is, name the computer or name the movie or name the video game, will get a t-shirt. So I'm about to do that, but before I do, I want to encourage you to in the chat to ask questions right as we go all the way through this. These are much better when they're highly interactive. And a lot of the most fun sessions we have are ones where the attendees ask really challenging questions and get us to kind of work through some things. So the chat is also, you have to send the chat to everyone, but the chat is also where you'll guess or not guess, where you'll say what my background is. Okay, let's see here. Let's choose a background. Let's start with something out of the history of computing. All right, what computer is that? It obviously has an Apple logo. You can't say Apple. Okay, you have to say what Apple. Anyone? It's not an Apple One. This is much later than the Apple One. This is after the Apple III, or right around the same time. Okay, well, maybe I went too far back in history. This is the first mouse and keyboard Apple computer, the first one with a graphical interface and a mouse. Does anyone know? Has two names. Either one is okay. All right, we're not going to get it. It was called the Apple Lisa, and it came out just before the Macintosh, and it cost $10,000, and they sold like 9, something like that. Okay, let's get back to our topic at hand. We'll do more of them. I'll do some other kinds of backgrounds as we go forward. Okay, so let's talk about cloud security in the software development lifecycle. Hearing people talk about shift left has gotten already kind of old. What we mean by shift left, and we at Fugue believe that what you really need to do is kind of shift everywhere, that security needs to be embedded, certainly in the early part of the SDLC, which we're going to be focused on primarily today as it relates to cloud infrastructure code, but it also needs to be maintained all the way through the SDLC. So as we talk about OPA for Open Policy Agent for Policy as Code, we're going to show you how that relates to Terraform and Cloudformation, but those same policies with Fugue can be used in the running infrastructure. In other words, after the infrastructure as code has done deployment, and also at deployment time, where if you integrate these policies into your CI/CD pipeline, they can do things like break builds and say, no, we're not going to deploy this because it has security issues. So what we're really talking about here is from development through deployment and into the runtime, having policy as code driving security for your cloud infrastructure. And I think, yeah, so we're going to talk we're going to talk a lot today about Open Policy Agent. The folks at Styra who created it call it OPA, not OPA. So I'll use their OPA, pronunciation. So what is it? And I'm going to get more into details, and Jasper's going to get a lot into details. So what it is it's a runtime that includes a declarative language for expressing policy. That language is called Rego. Rego is largely based on a query language called Datalog. So it's not SQL, but it has kind of similar aspirations and goals, if a pretty different implementation. And there are reasons why Rego is really powerful for this use case. OPA allows context-aware rule capabilities. So, in a simple case, there may not be a whole lot of context. You might just say, don't let SSH ports be open to the world, and that's kind of the scope. But because it's a real language, because it's a powerful one and can traverse larger data structures, JSON data structures, you can also do much more sophisticated things with it around the context in which a security group or an IAM policy or something is deployed. It's really becoming the open standard for policy as code, not like standards body standard. It's not one of those. Frankly, in many cases, the better open source stuff that becomes de facto standard is not designed by a committee. It's designed by a relatively small number of folks who really use it, and at least that's been my experience. So OPA is a cloud native computing foundation project, and it's getting very wide adoption, as I'll show you, and becoming kind of the standard, de facto standard way to do this stuff. Mostly, OPA has been used for policies related to Kubernetes, particularly around defining transaction boundaries and authorizations. We're going to show you today a very different use case for OPA, which is your cloud posture, the security of your cloud infrastructure as code, and then running environments. So it's applicable to a wide range of cloud native use cases. All right, so what we're going to be showing today is our open source implementation of OPA for cloud security, okay? And we call it Regula. It's a policy engine that works for IAC security. So here it says, Regula is an open source policy engine for checking infrastructure as code and cloud resources for security and compliance. We'll show you the GitHub. We'll put it in the chat. You can download it and use it. Basically, the way it works is you have infrastructure as code inputs. Typically, that's going to be pointing to a repo, Git repo normally. And so it will look for Cloudformation templates, Terraform templates. It can also operate on Terraform plans, and Jasper can kind of help us understand the difference as we get into that. And then there are a collection of Rego policies. There's a bunch in the open source project, and you can add your own, of course. And in Fugue commercial products, we have a whole lot of those. And then it is going to tell you whether or not your infrastructure as code templates have dangerous misconfigurations from a security perspective. And it integrates very nicely into CI/CD and testing automation. So it integrates, a lot of folks are using conf test now, works right with that out of the box, Jenkins, Circle CI, GitHub Actions, et cetera, et cetera. It's designed to be integrated with those things into a workflow. Okay, that's enough slides. Let's stop slide showing here. And let's switch to a web browser. And the first thing I'm going to show you here, are you still seeing my screen, Drew?
Yep, looks fine.
Okay, great. Zoom lost its little indicator for me. So, okay, this is the OPA website. It's www.openpolicyagent.org. And you can see here it's policy control for native cloud environments. The good folks at Styra are the principal authors. We are contributors over here at Fugue. We're very early adopters. And you can see here some code examples. They have a playground up on their site. Interestingly, you can run OPA as a daemon. So if you want to host the OPA microservice, you can do that. With Regula, we're using it as a library for IAC, but it deploys either way. One of the other really nice things about OPA, because of its broad applicability to policy as code problems, is your engineers will, as a technology like this starts to gain in popularity as it is, you're going to start to see more and more engineers who already know it, and your engineers are going to be motivated to learn it versus something proprietary. Let's quick take a look at the GitHub repo for the OPA project, and it's right here, GitHub Open Policy Agent /OPA. I'll put this in the chat for you. Oh no, I want everyone, not just. Okay, there's the GitHub repo that I'm showing you. And you can see here all about Open Policy Agent. I want to show you the adopters list that they have. I'm sure there are many more, but these are the very notable adopters. And you'll see here Atlassian and Bank of New York Mellon, Capital One, Chef, Cloudflare, Fugue, of course, we were very early adopters, Goldman Sachs, Intuit, Netflix, enforcing access control in microservices. That's a very common use case for it. Pinterest. So these are very T-Mobile, these are very significant organizations. And every time I check this list, it gets longer. Okay, so it's actually a pretty great way to do policy as code, and one that is, nothing's future proof, but it's definitely on the upswing. It's very powerful. There's a lot you can do with it. Just briefly, I'm going to show our GitHub repo for Regula. I'll copy paste the link to this. And you might be wondering, well, if OPA already exists, why did you go and make another project? Well, Regula adds to OPA a lot of capabilities and convenience features for doing infrastructure as code security assessment. Okay, so Jasper is going to walk us through this stuff in a lot more detail, but I just wanted to get those links out there for you. So I'm going to stop my screen share, and I'm going to do, let's try one more background. And then we're going to pull Jasper in and start getting more into the brass tacks. And by the way, if you're not a developer, don't leave. We are going to make this make sense to you. You'll understand it. If you are a developer, you might, get more detail out of the conversation. But if you're a product manager or a security expert, security professional, this is for you too. Okay. All right, let's do a background if I can find where that is. So history of computing, I had gone too far back in the day. Let's do an anime. Okay, what is this? I'll try to scrunch down here. What is this anime? Oh, Jan, I hope I got that right. Nailed it right out of the gate. Ghost in the Shell. One of my all-time favorites. So Jan, you'll get a t-shirt, and Sivia will organize that with you in the chat. Awesome. Jasper, can I invite you in, please?
Hey.
Hey, good afternoon.
Hey,
so
Jasper.
yeah, why don't you give a brief introduction to yourself, a little about your background and what you do at Fugue, and then we'll jump in.
Yeah, so I'm an engineer at Fugue, have been for 5 years or more already. I've been there for a while. I originally come from sort of a languages and compilers background, and that's also how I joined Fugue, where I was initially working more as a compiler engineer. Then when we sort of started focusing more on security, we obviously sort of had a lot of questions around how we're going to tackle security in our product, and sort of like there were some language questions around that as well. And that's more or less the area I focus on now within Fugue. So really the OPA, the rule language, how we use it, and then obviously components that use this language as well.
Great. So a little bit, just briefly, I'm sorry, I'm looking at our notes here, and I promised to explain a little bit what is infrastructure as code, and I'll just do this very quickly verbally, and Jasper, if you have some screen stuff to share, maybe get that ready. Infrastructure as code, what we're really referring to there are things like Terraform and Cloudformation. To some degree, things like Ansible, but also Kubernetes manifests, things like that. It's code-based ways to define how your infrastructure in the cloud is deployed and configured. So Jasper, can you give us a little bit of a practical hands-on of Regula and OPA?
Yeah, I can talk through some stuff. So I hope everyone can see my screen. I have some Rego code right here on the left, and just sort of an evaluator on the right, a bash shell. And yeah, this is a sample of Rego code. So I guess maybe I want to do a more general introduction of Rego first, and sort of why we ended up with OPA. If you're doing policy as code, what you're really doing is testing configurations, and this really always comes down to looking at what a configuration is, and then either deciding if it's all fair game or if there are possible errors with it. And so, in order to do this, you want the language. You need to be able to express these policy rules, and there are a lot of choices out there. I'm not quite sure actually why we initially picked OPA. That happened before I was joining on this MVP. I think we just saw that it applied to Terraform and kind of went from there.
I can fill in a little bit on that, Jasper. So Yeah, a few years ago, we had kind of a skunkworks project looking at, we had our own policy language, infrastructure and policy language that Jasper was writing a compiler for. But we saw that Terraform and Cloudformation were really succeeding in the market. And we wanted to take all the work we had done around policy as code and use something that was looked like it might have the ability to become a bit of a standard. And some of the criteria for us in making that decision were around what you could actually accomplish with it, in the sense of simple things should be easy, right? But arbitrarily complex things should be doable. And we found that OPA was the one thing out there that met those criteria.
Yeah, and I think I compare this mainly to, well, either obviously doing our own thing, Rego, of course, and other alternatives are maybe SQL, or using like a graph database with JSON support, or just using a regular language like JavaScript or Python. But I think OPA Rego has so many good things that makes it like ideal for this use case. If you look at the policy I have right here, you can, I think an important aspect of these languages is because you're always looking at configurations, because it's IAC, you're always sort of looking at these nested structures. And I think one of other example of a query language like that is Jeugt. Maybe you know this, Josh. You can kind of like run JSON snippets through it. And Jeugt has a sort of convenient syntax where you can just access fields. And I think that's something you definitely want in a language, just being able to easily deal with JSON and nested structures. But obviously you can see that this whole language, like, it's much more complicated than that, right? We don't just have this rule. And there's a number of configuration checkers that have languages that just maybe do sort of this more flat out statement style, where you just kind of like specify this field should be bigger than this other field, or it shouldn't be equal to this string, and so on. And those certainly have their use as well, but obviously they're not extensible enough for if you want to do more proper IAC, especially if you want to look at multiple resources at the same time. And we'll sort of get into later why that's important. But yeah, like, its flexibility is a big win for us. Also, the fact that compared to other query languages like maybe SQL, you can just share code however you want. You can reuse bits of code. You can create these modules. Show an example of that later, where you just like solve all the intricacies with security groups, and then other developers can reuse these libraries as well. So at Fugue, we're always looking at different configurations and validating those. We obviously want to write good software and test this as well. And I think this is another advantage that OPA has. It has this sort of built-in testing framework, where you can just pass a file to OPA test and it'll test it for us. So this also means that if you have a configuration that you know is faulty for your company policy, you can kind of freeze this in and that sort of like ensure that your rule continues to catch this. And then obviously, as Josh already said, like, the fact that it's all open source helps us a lot. So you may notice that it's quite different compared to other languages that you may be familiar with, like JavaScript or Python, for example. But I think there's a few simple tricks that you can kind of learn that makes it a lot easier to pick up. Right, the way I usually read queries, for example, is you read them kind of like with the header first, but it's only this is sort of the return value in a classical programming language. So whenever you're reading queries, you would kind of want to go through them in a fashion where you read the body of the rule first. So like if the inputted role is an admin, then you kind of have more statements. And then this would be the equivalent to sort of doing a return true in traditional languages. But the writing order in Rego is a bit simple. And while this looks weird at first, it's very neat because you kind of like get to see everything at a bird's eye view as well if you're just scanning for the top level definitions.
So Jasper, as I'm looking at this, looking through, it looks like the first thing that happens on line 1 is we're defining. Well, are we defining a package there? Importing a package?
Right. So the OPA uses packages so you can group code together. Here on the first line, we're simply you can call it defining the package or maybe opening the package. If I open an interpreter on the site, you can see that, so I've loaded the file right here, and I can kind of go and look at it like this, for example. Currently allow is not allowed because there's no input. But we can also switch to this package. And now we can just look at allow, or for example, allow with input as myself. We can see we get it true. This width allows us to quickly test statements with other inputs. So yeah, what we're doing is simply defining a package here. You always have to do this in OPA, and then we can put a bunch of declarations where we can either have defaults or we can have simple queries. You can have normal JSON style data as well. A very good advantage of OPA is that everything that's valid JSON is also valid Rego code. So you can kind of spit it in, or if you're doing sort of pre-processing, it's very useful.
Got it. So if I'm reading this correctly, the first thing that you're saying on line 3 is by default, allow is going to evaluate to false. So that's a default denial in other terms. But then the allow equals true only becomes allow will return false unless the input role is admin of the user you're inputting. Is that how to read this?
That's correct. So queries in Rego are additive, so you can have multiple definitions of allow where you specify different conditions. So the way to read this is here is the sort of the return value, and then you can put a number of conditions here. And then really this first line here only applies if all the conditions here are true.
Got it. Well, we've got a couple of questions. The first one from Sam: does Regula support IAC from other CSPs, in particular Azure Research Manager? I think at present we haven't included ARM, but it is in roadmap for us. So I can't give you an exact date, Sam, but we do intend to cover it. And then the second question also from Sam: how often is the library of rules updated that Regula evaluates templates against? Jasper, could you take that one?
So I think we use the same release cycle that we use for the main Fugue project. So that's every 2 weeks. And then that's sort of the time where we roll out new rules and also update existing rules.
Great. Yeah, so we're we're on a 2-week sprint cycle and a 2-week release cycle at Fugue for everything we work on, our commercial product, our SaaS offering, as well as Regula open source. So Sam, I hope we answered your questions adequately. All right. Let's see here. So what you're showing us here has to do with input roles. What about some kind of Regula IAC?
Yeah, maybe I can make a jump to IAC here, because this is kind of just a very simple example of a policy where what we're evaluating is just right here, these sort of made up user accounts. But what we actually want to talk about is IAC, of course. So in OPA Rego, you're always writing rules against the what we call the input document. And that's also what you're validating here. If we go to an example of some IAC, we have a Terraform file here. We can obviously not use this HCL file directly as an input document to Rego. So what usually happens is we use Terraform to first convert this to a plan file. You can do this like this. Is just using the example here with an IAM user and a key. Writes this to tmp.plan. Then I can convert this to JSON. And then we get a Terraform plan. I can pretty it up a little bit. But basically that is what a Terraform plan looks like. If I open that in an editor, I have a version here as well. This is sort of the input document that you're writing real rules against. If you're just using OPA and checking for misconfigurations, and I can look at a rule for that as well. So if I quickly jump back to the example, what we'd like to do is we'd like to check that these tags are set everywhere. So we want every resource to have a department tag. If I jump back to the plan, we can see that this input document that Terraform provides is actually rather big, but we can find the tags down in here. But yeah, this is not a very pleasant document to work with. Either way, because OPA Rego is still very flexible, and we can do all sorts of queries. We can write the rule for that. I can jump to this. So this is a rule. Actually, let me delete the statement here, although we could leave that in. So this is a rule that checks that this department tag is present. I can give an example of running that as well. So if I just want to run something with plain Rego, we can always use OPA eval. Just uses a standard built-in evaluator, and then we pass the plan as input, and we put this rule that you see here on the left, and then we specify the sort of the thing to evaluate, which is this deny in our package statement here. And as we can see, this rule is actually rather complicated. So we see that right here, we're looking at the input document. Then we have to look in planned values. We look at the root module, and only then can we actually look at the resource. If I jump back to the plan, you can kind of see that it follows the normal plan JSON spit out by Terraform, but it's not very pleasant to work with. You also see this values in here that we need to look at. But yes, so this is an example of just like a very straight, simple IAC rule. Obviously, there's also some problems with it. you can see that we're looking at the root module here of the Terraform. A good question is, for example, what happens if I have Terraform files with many modules and so on? Do I then have to kind of like search through other modules as well? There's this, we take resource ID from the resource address, which is as in the Terraform here. There's also questions like if we have multiple modules, our resources ID is unique. There's actually two kind of rules we can write like this. In the Terraform plan, there's different sections. There's planned values, which we skipped here, but there's also resource changes, which is how Terraform declares the changes it's going to make. So instead of writing this rule against the planned values, another way that we could do that is write it against the resource changes. And you can see the way we need to address these tags is very different, and both are sort of equally as complicated, I think. As you can see, the result is the same. But yeah, all these sort of disadvantages, I've now kind of iterated there are problems with this rule are why you would consider using Regula. Like these are the problems we're trying to solve. For example, this last problem with do we look at planned values or do you look at resource changes? It's really a mix of the both. Like you really want to take sort of a union of the both, because pieces of information are in only the first section and other pieces of information are really only in a later section.
So what you're showing here is if you were to take OPA off the shelf without Regula and try
Right.
to interrogate Terraform plans, all the complexities there, what's it
Yes.
look like with Regula?
Right. So if we use Regula, we can simply just remove a lot of complexity, and I think that's also one of the ideas where Regula spawned. Right. If we try to take all of this boilerplate out of the rule, so the rules can be as simple as possible, and we try to put this all in like a nice Regula library. And an example rule using Regula. So here's the same rule written using Regula. There's obviously it looks a bit familiar. We already have a package name, of course. So Regula uses this convention that you have to use the rules namespace for any rules. And that's sort of how it picks up all the rules you want to run, because that way people can just use like separate files for all of their rules and kind of like have a nice distribution that way. So what's very common in rules is that you only really care about a single resource type. I think, in fact, like a majority of the rules is this, where you just want to evaluate a simple check, like does this attribute match this or that? And Regula supports two kinds of rules. I'm not going to go into full detail, but this is an example of a simple one where we just care about like a single resource type. We have a false allow default again, and then we just only allow if this tag exists. And you see I switched from a deny to an allow because it's just slightly easier to write, and we support both formats. If I can run this rule against, so because this is just obviously Rego code, and I can run this as well using the plain evaluator. So I'm just using plain OPA again. I'm using just the same JSON plan that's kind of complex. I'm using our own rule that we wrote, so the regular rule. And then I'm additionally passing in the Regula library to the plain OPA evaluator. And then I just pull out the report. Like usually you wouldn't do all of this with Regula. You would just use the standard CLI, which is just regular run. But this sort of shows how it's still just plain Rego code, and that's what really cool about this. And the output is of course a little different, but the core information is still there, and you even get a bunch more information.
Great. So what does the output look like with Regula when you're doing a Regula scan? I mean, we're seeing here a lot of like JSON output, and sometimes that might be desirable, but what does it look like to run, for example, Regula locally or in a CI/CD pipeline?
Obviously, with Regula, this becomes a lot easier. As you can see, you just get plain text output. This is, of course, using not our own rule. I can pass that in as well. And I'll only use our own rules, and you can see that we have our own rule failing here. But then, obviously, if you run Regula on with all the built-in rules, you get a lot more results.
Sure. So just for the folks in the audience who are maybe not programmers or engineers, and some of this has been a little bit confusing, what we're showing here is with straight out of the box OPA, doing infrastructure as code checking is actually quite complex. And with Regula, what we've done is using just OPA. So Regula is mostly written in Rego, which is the OPA language. We've really made it a much better user experience and much easier to get started, including things like you can see there low on that FGR00272 IAM users should be members of at least one group, followed by low, that's the severity. And so Regula comes with a lot of rules. Jasper here is showing you just one about the tags, but you get dozens of rules with Regula that will check these things.
Yeah, and obviously this was an example of a very simple rule. Within Regula we ship also much more complex rules. An example of this is a rule that checks for admin privileges in IAM templates, which is another hot topic. And as you can see, this it still follows it still looks like a normal rule, but instead we're running on multiple resource types, with checking a bunch of different types here. I'm not gonna obviously walk through this code in all detail, but I think the important takeaway is really that it's possible to write these very complex policies. And not only that, you can, if you have these very complex policies and you want to make sort of like slight variations of these, obviously you want to share this code as well. And that's why Regula also has these libraries written within Rego, of course, that just make writing these rules a lot easier. Like for example, there's so many exceptions with security groups and things you need to take into account. And those are the things we really try to simplify here. And if I then, maybe I can jump over to a rule that's using this library. Obviously, this always looks a bit intimidating, but we always have some metadata about a rule as well to make things show up nice in reports and so on if you do regular run or in this SaaS. But you can see that using this library, rules that are inherently a bit complex to write. Like, for example, do you allow ingress from anywhere to port 22? Can also become very, very short.
Well, and I think that's a really important point to make, that with Rego, you can do I said earlier, when you're working with a language, what you want is the ability for simple things to be easy to do and arbitrarily complex things to be possible to do. A sort of connected concept is, by writing things like libraries, you should be able to make very complex things simple. And that's really what Jasper's showing here, is how much Regula really simplifies the infrastructure as code universe of data structures, so that you can write very simple Rego rules yourself by leveraging those libraries. Is that a fair description, Jasper?
Yeah, I think that's exactly it.
Okay, we've got about 8 minutes. Well, I don't want to stop you, Jasper. Did you have anything else to show us? Because I've got a couple things I want to.
You can take it away, and if there's questions in the chat or something, I can always answer those as well.
Yeah, so ask any questions in the chat, and or in the Q&A. We prefer the chat, and we'll answer them verbally. All right. Why don't I do one more background, and then I'll share my screen for a minute. Let's see, what should we do this time? We did an anime and we did a history of computing. Why don't we do a game, a video game? Name this game series. Oh, Brent got it. Bang. Yes, this is, I think, from Near Replicant, but another one in the series is Near Automata. Really interesting games exploring consciousness, artificial intelligence, and what it means to be an ethical being. Okay, I do want to share my screen.
Hey, Josh.
Yes.
Can we do one more, just because we missed that first one and I'm feeling particularly generous today?
All right, I let's see what I got. Oops, I pulled up the wrong dialog box. Let's do this one. Let's see. All right, let's do a movie. This is from the student film of the most successful science fiction director in history. Anyone know? It's not Terminator. It's way before. This is actually from the remake. I think the original was in like 1970 or 71. And if you can name the director or the film, we'll give it to you. I have tough ones today for some reason, Sivia. On this box, I think last time people were just getting them instantly, and so I maybe went too far into geek esoterica.
I don't know. You're just tough tonight.
Yeah. All right, we'll give you one more minute. All right, I don't think so. This is a film. It's not James Cameron. This is George Lucas's final student project. It's I think Scott got it right before I said it. The film's called THX 1138. I can't really recommend it, to be honest. I mean, it's okay. It's all right. It's very stylish, I'll say that. Okay, let's see here. I'm going to share my web browser here, and I'm just going to briefly show you. So Jasper was showing these rule results in a command line way, right? Which is what you want when you're sitting there, writing Terraform code or CloudFormation code or what have you, or Kubernetes manifests, or you have it integrated into a CI/CD pipeline. But once you're in the runtime, the way we use the exact same OPA policies, the same Rego policies. Oops, get this out of that screen. And the exact same policies, and we analyze the running environment. So what Jasper's been showing you is infrastructure as code. What this diagram is showing you in the Fugue SaaS is that same approach with the same policies looking at running infrastructure. And here you can see, we've got the internet on the left going into a VPC network, a load balancer, some compute instances, and a database. And a number of these things have been lit red. That means they're failing OPA tests. So if I go to this one, you can see right here, this EC2 instance has a directly public-facing IP address, which is considered not a great idea. So this can be used all the way through that SDLC. So like going back over to my slides, what Jasper was showing you was on the left side of this in development with Terraform CloudFormation, and what I was just showing you is in the runtime. And of course, we can do at Fugue, we can do the runtime in AWS, Azure, Google, no matter what kind of IAC or no IAC you used. All right, we're coming up on the top of the hour. So additional resources, here's some links. Oh yeah, let me pull up regula.dev. So just do it this way. So regula.dev are the Regula docs. I'll post that in the chat as well. You'll see that there's quite a bit in here about getting started with Regula, and right here, getting started, Mac OS and Linux. You can get the binary for whatever platform you're on there. You can run on Windows, any kind of Linux, etc. So that's all there. And do we have any other questions?
I'm not seeing any, but please pop any questions that you have last minute into the chat as we near our close.
Okay, Drew, why don't I turn it back over to, okay, we had just got a question. Do we have any GUI / drag and drop option that a non-programmer can use and it generates policy behind the scenes? Watch this space. So the answer today is no. But Regula comes with a lot of built-in policies based on CIS, and Fugue, the commercial product, has hundreds and hundreds of these out of the box. So we can cover a lot of that stuff for you. Jurgens asks, how often do you scan / sync with the runtime? And do you detect drift from the build definition of the runtime? We scan / sync as often as you like, is the short form. And yes, we actually, I love that question. Let's get it back. So in Fugue, what we do when we scan an environment, we don't just run OPA policies on it. We capture the complete configuration state of that entire cloud infrastructure. And we can do that both in the runtime and at the IAC layer. Oh, I thought I quit my notification. So, and we detect drift. We do precisely that. So, and drift is of course independent of policy, right? So if something changes, that change may newly violate a policy, or it may just be a change that doesn't trigger an OPA response, and Fugue tracks both of those things. So yes, absolutely.
I think to build on that question, Josh, one misconception that's not that uncommon out there is, if we get our IAC, our Terraform code, if you will, in a secure state and deploy it, then we're good to go and we don't need to worry about the runtime. And that might be a little bit more the case with, say, like application code. If you get it right on the left side, it's probably not going to really mutate out from under you. But with cloud infrastructure secure, I would just say you just never turn your back on the runtime.
Oh boy, that is very true. And it's a really good point to bring up. So if I'm writing a Go program and I compile it in my CI/CD process, it is unlikely that that Go program's behavior will be changed out from under the source code while it's running. I mean, there are some kind of esoteric ways to do that, or, if you're not doing static linking or something. But for the most part, when you're checking application code, if you're looking at the source code, you have a pretty good idea that you are, in fact, checking what's running. Infrastructure as code is totally different in the following way. When you have that Terraform template or Azure Resource Manager template that builds out a virtual machine or an EC2 instance, that's fine and well. And you might check it in advance to make sure, for example, the IAM role policy that's attached to the EC2 instance is safe, or whatever other, I mean, we have lots and lots of EC2 checks, and you deploy it. Well, is it guaranteed to remain that way? Absolutely not. It is very likely to be changed, to be mutated outside of the IAC pipeline over time. Okay, so you define it once with Terraform, you say, well, it was good when it was built. As soon as that thing hits the air, right, as soon as it's live and running, all the time, there is the possibility of it being changed in, for example, a maintenance window, or through other mutation that's done manually, or at the console, or through a script running or something like this. So if you really want your IAC templates to reflect what's running in production, you have to constantly watch production or the deployed environment to make sure it's not mutating away from what that IAC code defined. And we see at Fugue, I mean, we manage millions of resources from a security perspective for our customers. So we have a very broad view into what happens out there. And both here at Fugue and when I was at AWS, I'd see this all the time, where people thought they knew the state of things, but in fact, the state of things was changing, and they didn't really have an adequate way to keep track of it. So we do both.
Yeah, it's essential to get your IAC in a secure and compliant state, but you always have to keep an eye on the runtime, because it's going to drift out from under you. So
yeah, absolutely.
Awesome, great question. Thank you for that. So yeah, we'll move to wrap. We've gone over a little bit. Just want to throw out, if anybody out there, wants to, get on the horn with some of our security engineers, our solutions engineers, to just kind of talk about your specific kind of cloud security use case, AWS, Azure, Google Cloud, AWS Cloudformation, Terraform, etc. We'd be happy to kind of just workshop some of your issues with you and walk through what some of the solutions might be, with Regula, with Fugue, jointly together, the advantages of being able to use the same policies across the development lifecycle, from infrastructure as code through the runtime. Would love to have an opportunity to meet you and help you kind of think a little bit more critically about your problems, give you some new perspectives, etc. So do reach out to us. We're at hello@fugue.co or sales@fugue.co. If you want to get moving on Fugue, we guarantee your success, both kind of immediate success and long-lasting success. You'll get a simplified, actionable cloud compliance assessment in just 15 minutes of pointing Fugue at your environment. You get a lot of rich information about where you stand and kind of build that roadmap to bring it into compliance as quickly as possible. So definitely reach out to us, and want to thank everybody for taking some time with us today. Thank you, Jasper. Thank you, Josh. Thank you, Sivia. Enjoy the rest of your day.